Boom! Yes, folks, Hume here again. How are you doing? In this video, I want to take a few minutes to discuss a particular type of fraction. This particular type of fraction receives little to no attention at all in traditional discussions of mathematics. That is what they refer to in some quarters as a whole fraction. What is a whole fraction? Well, we will start the discussion by talking about fractions that we are already familiar with. Right? We know about the proper fraction and we also know about the improper fraction. But nestled in there somewhere is what we can refer to as a whole fraction. So let us do a brief recap. Alright? We know, generally speaking, that any fraction can be written as a numerator over a denominator. Alright? We know also that when the numerator is less than the denominator, that is what we refer to as a proper fraction. Right? An example of a proper fraction would be 3 over 5. Once the numerator is less than the denominator. We know also that when the numerator is greater than the denominator, we have what we refer to as an improper fraction. Right? An improper fraction, and again, an example of an improper fraction will be something like 7 over 5. We're using the same denominator for simplicity, so you could see the case where the numerator is less than the denominator, and I can see the case here where the numerator is greater than the denominator. What happens, however, when n is equal to d? This is what we're referring to in our discussion as the whole fraction. And if the denominator is 5, then the whole fraction would be 5 over 5. Right? Why we don't have this as a particular type of fraction all on its own? One of the reasons for that is simply that in some circles, in some mathematical circles, where people discussing maths and theory and all this kind of thing, they actually include this situation with the improper fraction. So what they would normally do, they would say that the proper fraction would be where n is less than the numerator is less than the denominator. But for the case of the improper fraction, they will say that the numerator is greater than or equal to the denominator. So in this case, your 3 over 5 would be a proper fraction. Your 7 over 5 would be an improper fraction. These two we clear about. There's no doubt, there's no ambiguity where that is concerned. What about this? Some people include this in improper fraction. For my own purposes, as somebody, as a practitioner of mathematics, as someone who teaches mathematics, I would prefer to actually take that particular case where the numerator is equal to the denominator and give that a special category all on its own. And the reason why I would do that is because that technique of using the whole fraction where the numerator is equal to the denominator, that is one of the most effective and useful techniques in mathematics. That is used in a variety of different situations. Simple example, in some of my earlier videos where I spoke about the addition and the subtraction of fractions, one of the things that I did is use the whole fraction when you're adding and subtracting fractions. Very, very, very important technique. Right? I didn't use the vocabulary then, but at this point in time in thinking about it here, I wonder to myself, is there a particular word or a particular phrase for this thing? Right? We could use the whole concept of the whole fraction when we're talking about surds, or even when we're dealing with complex numbers. where we have to rationalize the denominator of a surd or rationalize the denominator of a complex number. And again, in a case like that, we could use the whole fraction as a very convenient technique. We could use the whole fraction in multiplication and division. There are a whole host of areas where the simple ability to express the number 1 as a fraction, where the numerator and the denominator are equal, where that technique is useful. And with that technique, there is no real limitation to what values the numerator and the denominator could take. It simply depends on whatever situation we find ourselves in. So for example, in this case where we actually were talking about some examples of the different types of fractions, we use the denominator as 5. So a proper fraction of 5, a proper fraction, where the denominator is 5, the numerator must be less than 5. An improper fraction where the denominator is 5, the numerator must be greater than 5. And for our purposes, if we're talking about the whole fraction, then if the denominator is 5, then the numerator must also be 5. And we could do that with any number that we choose, whether the number is positive, whether the number is negative, whether the number is rational or irrational. We could do it with decimals even. Anything we could think of really, we could use to construct a whole fraction depending on whatever situation we find ourselves in. So let me do some random examples. So some random examples of a whole fraction. Right? So we already saw 5 over 5 as a whole fraction. We can say, for the sake of argument, that we could have a whole fraction, let me say minus 9 over minus 9. That too is a whole fraction. We can say, for example, let me use a surd. We can say root 3 over root 3. That too is a whole fraction. And we could talk about different types of surd. This here is a simple surd that we're using. How about a compound surd? We could say 2 minus root 3 over 2 minus root 3. Once the numerator and the denominator are the same, that too is a whole fraction. Now what about complex numbers? We could say, let me start with imaginary numbers. 8i over 8i. That is a whole fraction. We might want to express the number 1 as 8i over 8i for some particular purpose, for some particular situation where 8i is at the center of it all. How about a complex number? Right? Let me say 7 plus 8i over 7 plus 8i. That too is a whole fraction. Complex number as numerator, complex number as denominator. Once they equal, that's all we need. Alright? Anything at all we could think of. How about an exponent? Let me switch the color of the ink now. We could say e to the power of minus 3x over e to the power of minus 3x is equal to 1. That's a whole fraction too. There are situations where you might want to express the number 1 as a numerator and a denominator, where the numerator and the denominator are in exponential form. How about logs? We could do the same thing with logs. If we say ln 7 over ln, or ln 7, log to the base e, of course. Right? Same story, numerator over denominator, etc., etc., etc. Now, of course, if you're not familiar with some of these things, don't make it a problem. The whole point of this conversation is that whatever level of mathematics that you're operating at, the knowledge and the ability, the knowledge of and the ability to express the number 1 as a fraction is a useful technique. And if you're expressing the number 1 as a fraction, then the only possible manifestation of that would be a situation where the numerator and the denominator are the same, are equal, right? And that is why it is referred to as a whole fraction, because when the numerator and the denominator are the same, the final value of the fraction is equal to 1. 1 is a whole. Let me go back to these 3 examples just to illustrate that. So with a proper fraction, 3/5, that would be less than 1. As a decimal, that would be 0.6. 0 wholes, 6 parts out of 10, 0.6. As an improper fraction, you have 7/5, which if we write this as a mixed number, we'll get 1 and 2/5. Right? So it will be 1 whole plus 2 parts out of 5. 2 parts out of 5 as a decimal is 1.4, 1 and something, 1.4. And of course, with 5/5, that's equal to 1. 1 whole. Nothing more, nothing less. So I trust and I hope that this little video has been informative and that it would stroke and stoke your curiosity at some level. And the reason why I take the time to actually discuss this is because I haven't seen it really given much attention, to be quite honest. I am sure maybe somewhere would have written about it or spoken about it. I don't know. Maybe, maybe not. Right? You can't assume that somebody didn't do something just because you didn't see it. But having not seen it and doing this, making maths videos and stuff, I say, well, all right, we can make a little video on it. We talk about it, we discuss it, we explain it, we illustrate it, we demonstrate it. And hopefully, it would now form part of your overall mathematical understanding and your overall mathematical practice. All right? So, take it as that, and I am sure at some point in time in your mathematical journey, you will find that this concept, the concept of the whole fraction, will be useful. So go forth and enjoy it.